Good morning, class. Now, most of you guys, I think, are understanding properly. There aren't many questions. If you think the class as a whole could benefit from having one day, instead of giving a practice video, I can select specific examples from the book, from the classes we've seen that week, and we can leave, say, Fridays to just do exercises from everything we've done, and then schedule Skype calls individually or in small groups. I mean, not everybody has to do it, in order to answer specific questions for classes throughout that week. If you think you would benefit from that kind of interaction of one day for doing specific problems, and if you have questions, you can ask me via Skype or voicemail, just have an interactive small class, that's fine. Again, not everyone has to log in, only the people who have questions. If you think that's something you might like or benefit from, let me know and we can do it. That's fine. So today we're going to finish 6.1 with a very small theoretical class, 6.1, and we're going to begin 6.2, which is matrix multiplication, which is very, very confusing initially. Once you wrap your head around matrix multiplication, it's very mechanical. I mean, literally, it's only like 2 steps, but it's confusing to work with matrices. People mix up the rows, the columns. Sometimes if I don't practice properly before this class, I get confused. It's not very straightforward. Again, there's not a lot of processes involved. It's just multiplying and adding. That's all you have to do. But the way you manipulate the elements within the matrix is somewhat confusing. So let's begin with Gauss-Jordan elimination. First of all, the other day we saw Gaussian elimination. We turned a linear equation system into an augmented matrix. Again, just numbers in the matrix. And then we turned that matrix into what's called, a row, or that augmented matrix into row echelon form, which is all zeros until I reach a 1, and every number below that 1 has to be a 0. All zeros until I reach a 1, every number below that 1 has to be a 0. That's called row echelon form. Today, you're going to know what reduced row echelon form means. And again, reduced row echelon is pretty much the exact same thing, only there's only zeros and ones in your matrix. Okay, only zeros and 1, at least on the left hand side, and then we have specific values. So now you know this variable is this value, this variable is this value, this variable is this value. In order to do this, we repeat the exact same thing we did to get rid of these zeros by multiplying your first variable to get rid of zeros. And then you continue, but we also get rid of these 2 variables and these 2 variables. So it's a little bit more work, but it's the exact same process. Again, you just use your 1s to get rid of everything else that isn't a 1. Okay, that's reduced row echelon. Again, row echelon could be different numbers here. That's echelon form. Reduced row echelon, zeros and 1s. Now, again, sometimes I might ask you for a reduce, sometimes, just solve. So depending on what the problem tells you, you might have to work with a different fashion. Now, one of the other concepts we're going to go over is no solution and infinitely many solutions. Now, when we were working with linear equation systems, I bet you remember, that was a pain in the butt. I mean, having to substitute and eliminate and carry the variables, and it was not fun. It was not fun. But when you're working with augmented matrices, it's incredibly simple. If you're left with a row that looks like this, for example, let's say this is an actual matrix. If you end up with a row that looks like this, 0 equals 2, in math, that translates to this. That's an inequality. Sometimes you'll see that when you add your rows, one row just, boom, cancels out. When that row cancels out, no solution to that matrix. Infinite many solutions is similar, but instead of ending with a value, also the value on the right-hand side cancels out, and you're left with an equality, 0 equals 0. When that happens, you just say infinite many solutions. Done. So 0 equals a value, a non-zero value, no solution. 0 equals 0. It could be any row, by the way, not just the last one. But usually it happens in the last row because that you work from top to bottom. 0 equals 0, infinite many solutions. And you stop working. There's nothing else to look for. Okay, so I hope that's pretty clear. It's pretty simple theoretical end to 6.1. Now let's go over matrix multiplication. You will have to practice. Again, it's simple. It's incredibly simple. All you do is add and multiply, but it is very confusing visually and mentally. See how it works. So first of all, let's go over to page 376 and let's go over example 1. I'm given that matrix A equals 3, 4, negative 1, 0. And I'm told that matrix B equals negative 2, 0, 6, 3, 5, 1. Okay, now, one thing to keep in mind. Normally, when you multiply, there's a property that tells us that the order of the product, so the order of the multiplication really doesn't matter. 3 times 2 is the exact same thing as 2 times 3. Matrix multiplication, this property does not apply. There are some, so it's a directional process. You will see there are some cases when you can multiply one matrix to another. For example, sometimes you can multiply A times B, but you cannot multiply those exact same two matrices in the other direction. So, and you'll see why right now, pretty much. First of all, in order for two matrices, well, let's go over the dimensions. Okay, this matrix is 2 by 3, and this one is 2 by 2. These are the columns. These are the rows. These are the columns. These are the rows. Now, in order for me to multiply matrices, the columns of the first row must equal the number. So the amount. I have 2 columns in my first matrix, and that 2 must equal the rows in the second column. So the columns of my first matrix must equal the rows of my second matrix. Again, I think I did a mistake there, vocabulary-wise. Let me be very clear. The columns of the first matrix must be equal in number to the rows of the second matrix. What the book does, again, it's very useful. You put your dimensions under your matrices. Okay, so this one's going to be 2 by 2, 2 rows and 2 columns. This is 2 by 3, 2 rows and 3 columns. Now, when you put your dimensions, these two have to be equal in order for me to be able to multiply. The columns of the first matrix must equal the rows of the second matrix. So I can multiply. And the dimensions of the resulting matrix will be given by the other two numbers. So the end result will be a matrix with 2 rows and 3 columns. So again, all this process is done just to see if I am able to multiply and also what the dimensions of the resulting matrix will be. And why do I recommend you also check for the dimensions? Because some students go, Profe, pero I was given 2 very long matrices and I just ended up with a 2 by 3 answer or a 2 by 2 answer. That's fine. Again, depends on your dimensions. You might get a smaller matrix. You might get an, as far as size goes, dimensions goes, you might get a smaller matrix. You might get an identical dimension matrix. You might get a larger matrix. So again, don't look at this and expect a particular result. List your dimensions here, confirm they can be multiplied. The answer will be a 2 by 3 matrix. And we're going to confirm that right now. Okay, so now that I have actually confirmed they can be multiplied, let's begin multiplying. Now, again, here we have to flip mentally, because in order for me to multiply, the columns of the first must be equal to the rows of the second. But when we're doing the actual multiplication, we use the rows of the first and the columns of the second. So it's pretty much the opposite. In order to confirm multiplication, columns, rows. In order to do the actual process, rows, columns. It flips. So how do I do this? Let's begin by finding my first element. In order to find my first element, so this one up here, this one, what you have to do is do a whole bunch of multiplications and additions. So in order to find just this one element, again, the answer will look something like this. 2 rows, 3 columns. Let's find this element first. In order to find that element, what I do is I take the first row of the first matrix and the first column of the second matrix. And I multiply the elements here from left to right and here from top to bottom. So I multiply 3 times -2 is going to be -6, -1 times 3, -3. Again, the first element here and the first element here. 3 times -2, -6. The second element of the row and the second element of the column, -1 times 3, -3. Once you finish multiplying those, we add them and we end up with -9. So this first element is -9. So again, I took the first row and the first column. Now for this element, I'm going to continue with my first row, only now I'm going to use my second column of the second matrix. And I do the exact same process. 3 times 0 is 0, and the second element, -1, times the second element in the column from top to bottom is 5, so -5. Now I add -5. And now I continue with the first row and I go with the third column. 3 times 6 is 18. -1 times 1 is -1. 18 minus 1 is 17. So as you can see, I use the first row and all my columns to end up with the first row of the answer. I'm going to repeat the exact same process, but now I'm going to begin with my second row of the first matrix to get the second row of elements. So again, now let's use the second row and the first column. 4 times -2, -8. 0 times 3 is 0. When you add these, I end up with a -8. Now let's go with the second column. 4 times 0 is 0. 0 times 5 is 0. Even though that's a circle, let's just put a nice 0 there. And now I'm going to go over my third column. 4 times 6 is 24. 0 times 1 is 0. 24 plus 0 is 24. And that's pretty much the resultant matrix. You can check the book, the answer is correct. Now, one thing to keep in mind. The book puts all the additions and multiplications you can see right there in a very, very large matrix. I do not recommend it because it gets very confusing when you multiply large matrices. What I recommend is once you know your dimensions, you build your matrix for your answers so you know more or less what to expect. You do all the processes outside of your answer matrix or resultant matrix, and then you just plug in the answers. Because again, if you're going to do all those numbers with pluses and minuses and you're going to bunch them up in a matrix, you're going to get confused. Again, it's not incorrect. That's how the book does it. I do not recommend you do it that way. Put your answer so you know what to expect. Do all the operations somewhere else, close by, so I can check the process. Do it out here. And then you just plug in your answers very nicely. Okay? And I think that's pretty much it. Let's go over examples over the guided practice. Let's go over example B, and then let's do the guided practice together. and then we'll do a whole bunch of problems. So example B, they tell me to see if I can multiply matrix B times matrix A. I erased my matrices. I know that A is 3, 4, negative 1, 0, and B is negative 2, 0, 6, 3, 5, 1. So now, again, remember, I recommend also, when they're not in order, just place them in order. Even though you might have to write a little extra, go ahead and write a little extra. It's better to just take 30 seconds to write something correctly than to just try to mentalize where everything goes and then get it wrong. Again, if you want a 100, just write a little extra. So now let's see. The dimensions of this matrix are 2 by 3. The dimensions of this matrix are 2 by 2. 2 rows, 3 columns. 2 rows, 2 columns. I'm going to compare these two numbers. They are not equal. These two matrices cannot be multiplied. Nothing else needs to be done. So again, don't say, well, this one has 2 by 3 and this one is 2 by 2 and the numbers are, I got to compare this one. Don't do it like that. I mean, it's not incorrect, but trust me, you're going to do a mistake in a test. Believe me, I've seen many students do this. They think, it's not that simple. I just compare these two numbers. When you're under pressure, doing a whole bunch of exercises and you're tired, you're going to do mistakes. Just copy it, compare, and then if they can be multiplied, you got your dimensions right here. Okay, that takes care of example B. Now let's do guided practice, at least 1 or 2 guided practices together. So the first guided practice tells me to find AB and to find BA if possible. A is the, let me go ahead and AB and also BA if possible. Matrix A is the following matrix. 3, negative 2, 1, 0, negative 5, 4. And B is the following. Negative 6, 4, 1, negative 5, 7, 3. Okay, now let's first do AB. This is 2 by 3, and B is 2 by 3. These numbers are not identical. 2 rows, 3 columns. Can happen. Done. I'm done. AB does not, you can't multiply. And again, even though I told you to rewrite them, you can realize here that BA have the exact same dimensions. So if you flip just B and A, you're going to end up with the exact same result. No, you can't multiply them. You just can't. So the first one, you can't do AB and you cannot do BA. Now let's do the second guided practice, which is 1B on page 376. I'm told that A is the following. Negative 2, 0, 3, 5, negative 7, 1. And I'm told that B equals 2, 0, negative 1, 0, 9, 3. Again, I'm going to write my dimensions, 2 by 3, and I'm going to write my dimensions, 3 by 2. They are equal. So I can multiply them in this direction, and my resultant matrix, AB, will be 2 by 2. 2 by 2 elements. That's what I need to expect. So this is one of the cases I told you that bigger matrices will give you a smaller answer. That's fine, and you'll see. So again, and also you don't have to do the little arrow thing, but I like to do it because believe me, sounds simple, but you will get confused in the test. So again, I take the first row and the first column. Negative 2 by 2 is negative 4. 0 by negative 1 is 0, and 3 times 9 is 27. Imagine putting all these just in here. and then the second one here. You're gonna get, it's very, very messy when they're very big matrices. -4 plus 27 is, you subtract 23. That's my first element. Now I'm gonna take my first row and my second column. -2 times 0 is 0. 0 times 0 is 0. 3 times 3 is 9. That gives me this element. Now I'm gonna use the second row and I'm gonna jump back to the first column. 5 times 2 is 10. -7 times -1 is 7. 1 times 9 is 9. Remember, you multiply the numbers and then at the end you add all the results, just in case. 17, 26. And now I'm going to use the second row with the second column in order to find this particular element. Again, that's a circle, that's not a 0. I just put a placeholder there so you can just plug in the missing values. 5 times 0 is 0, -7 times 0 is 0, 1 times 3 is 3. Boom, that's matrix multiplication for you guys. Okay. Oh, one thing I didn't mention from theory, in 6.1 at the end, there is something that's matrix multiplication. We're done with matrices. Now I'm just gonna give you a small explanation from the end of chapter 6, and then, which is incredibly small, and then we'll just go over the homework. Now, when you're looking for one solution, no solution, infinite solutions, if the number of variables that you have is bigger than the number of equations that you have, it's either going to be no solution or infinite solutions. You cannot just have one solution. So if you have 4 variables and only 2 equations that use those variables, it's either going to be infinite or infinite or no solutions. That's it. That's all I was missing. So right now for matrix multiplication, I want you guys to do the following exercises from 1 through 8. And again, it says find AB and BA if possible. Do 1 through 8 on page 383. That's it for today's class. Again, if you think you might need the Skype, Teams, video chat session on Friday, that's fine. We'll just do a couple of very select important exercises to make sure you stay up to date with with the processes, and we can set that up. Otherwise, it's just going to be normal class, which is fine as well. So just let me know what you need. Have a great day. See you soon. Also, good job. The people, only one student is not turning in homework frequently. You know who you are. Please solve the problem, or your grades are going to just tank. They're going to tank. So just, it's not that much. Make sure you work daily. Unless you have an actual problem. If there's an emergency, let me know. We're human beings, and we're in a very interesting situation. Just let me know if you have problems, and that's fine. Take care.